Let's have a look at exercise 4.02 from the Gamma text, question 4. This time, unlike the previous question, we've got a fraction for only one part of the left-hand side. So left-hand side, I'll just write left-hand side and right-hand side so we can make a distinction between those two. But at the end of the day, we've only got the 3 is only under the x, not under the 2. So I don't need to multiply the whole thing by 3 to start with. By the way, I could if I wanted to do that. There'd be nothing wrong with doing that. As long as you follow the rules of algebra, you can do whichever way you want, as long as you're doing the same thing to both sides. But in this case, it really does make sense to get rid of the positive 2 first. And so I'm going to undo a plus 2. So let's restate the problem. I'll tackle the restated bit. And I want to get rid of a plus 2. I undo a plus 2 with a minus 2. And I take the 7. I'm going to undo that with a minus 2 as well. So 2 minus 2 is going to be 0, which leaves me on the left-hand side with an x over 3. I'll keep those equals under each other as best I can. 7 minus 2 is 5. And now I'm left with a x divided by 3. Well, I want to undo the divide by 3. To undo a divide by 3, I do a times by 3, or multiply by 3. Now, of course, with the 3 on the top and the 3 on the bottom, a 3 divided by a 3, which effectively that is, 3 divided by 3 is 1, and 1 times x is just x. So 5 times 3 is 15. Now, remember I just said that we could have multiplied the whole thing by 3. Didn't really matter if we did or didn't, but I just wanted to get rid of the plus 2 by subtracting 2 from both sides. But let's do it the other way now. Let's say we've got x on 3 plus 2 equals 7. I'll restate the problem. X on 3 plus 2 is 7. Now this time I am going to multiply everything by 3. Notice, of course, we have to multiply the whole of both sides by 3. So this one's easy enough. I can multiply the whole of that side by 3. But to multiply the whole of this side by 3, I'm going to have to write in fact, I'll put it in front of the x. I'll make it a coefficient. And I'll multiply this by 3 as well. So notice, of course, the answer is in fact 15. And let's see if that plays out in the same way. We're doing it slightly differently. But as long as we keep following these rules, it should all play out and get the same answer in the end. So we've got, first of all, 3 divided by 3 is 1. I'll put a 1 here, and 1 times x just leaves me with an x. Now we've got a plus 2 times 3 is 6, and we've got a 7 times 3 is 21. Oops, I'll write 27 there. So 21, okay. So now, next line, I want to get rid of that plus 6. So what do? I'm going to subtract 6 from both sides. There it is. Of course, 6 minus 6 is 0, leaving me with an x. 21 minus 6 is in fact 15. So notice, of course, we got the same answer that we got last time. It's just we took a slightly different path to getting there. So in the first time, I said, well, I want to get rid of the plus 2 because I want unknowns on the left side. There's an unknown, an x. And I want knowns, like the 2 and the 3 and the 7, on the right side. So I'm going to strip everything away so I'm left just with the x. So first of all, I remove the 2, leaving me with the x over 3. I remove the 3, leaving me just with the x. I'm removing everything from each side, stripping everything away until I'm just left with the basic x. And there it is. Not a very good x, really. Okay, same story on this side, except this time I said, well, why don't we just multiply everything by 3? So we did, and we ended up in exactly the same place, but we got it there in a different way, and the answer again was 15.